In this video, we're going to be looking at an introduction to limits. Right, perfect. So number one, they want us to find the limit s x of x squared minus x as x approaches 2. Right, the strategy when you do limits is you need to always start by direct substitution and see what you get, right? So this one, where I don't have the denominator, will always give me a solution. Sometimes the issue arises when I have a denominator which gives me 0 at the bottom. There are other techniques that we're going to do when we get that. So this one is just straightforward. The answer, we get it by directly substituting 2 to every x value there. So it's going to be where there was x, you put 2. Then there was x there. This becomes 4 minus 2, which becomes 2. So the limit of that function as x approaches 2 is 2. So which means the y values are also approaching 2. Right. Now, let's try this one. This one, if we try direct substitution, we're going to have 0 minus 1 over, we're going to have, sorry about that. We're going to have 1 minus 1 on top. So 1 minus 1 over 1 squared minus 1. This gives us 0 over 0. You never need to have a 0 at the bottom when you're doing limits because that means it's undefined. So in this case, if we do direct substitution, there is an issue, right? Perfect. So there is a technique that you are going to do first before you can do the direct substitution. So you are still going to say, okay, this can still be limit as x approaches 1. And ladies and gentlemen, the technique that you are going to use always, it's either you are going to rationalize, that is if you have roots, né? And if you have rational polynomials, you have to factorize them. All right. So in this case, I'm going to factorize the bottom. I can see that this is the difference of 2 squares. So let's factorize that. So it's going to be x plus 1, x minus 1. That is the difference of 2 squares. And then on top, it's x minus 1. And we can see that this becomes a limit as x approaches 1. This bracket will cancel with that one. So I'm left with 1 over x plus 1. Now I can do direct substitution, which is 1 plus 1. So the limit is half. So the limit of that function as x approaches 1 is half, right? Perfect. As long as you don't get 0 at the bottom, you are sorted. The only way you are restricted is to not get undefined. If you get 0 on top, it doesn't matter. It means that limit is 0. Because remember, 0 divided by anything, the answer will be 0. Right? By any number at the bottom. But if you have any number on top over 0, you have an issue. This is what you do not need. Right. Now let's indulge in number 3. Let's see. Remember, you're always going to test with direct substitution. Ladies and gentlemen, I'm sure that you can see that if I were to take this 0 and put it here, my solution is going to be 0. So which means I'm going to divide whatever I'll be dividing on top by 0, which is undefined. So I need to do some technique first, right? So can I factorize? No, but I can rationalize. If you have a root, you have to rationalize. Ne? Sharp. So if I have a square root in our level, they're either going to give us a square root or a cube root. Ne? So if I have a square root, I am going to use the fact that if I have difference of 2 squares, the answer is going to be a plus b, a minus b, right? If it was a cube root, you must know how to factorize cubes. Remember, to factorize cubes, you are basically saying a minus b, and then a times a gives you a squared, b times b gives you b squared, and then a times b gives you ab. I'm sure you've seen the order in which I get the values or the terms in the second bracket. If this sign is minus, which is the same as the original, this one switches. It's always opposites. The last one, it's always a plus. Okay, That was just a general refresher. So in this case, because I have a square root, this is a square root here. So I'm going to basically use the fact that, okay, if I have a square root, right, I can use the fact that there's a difference of two squares that can happen here. I'm going to multiply by its conjugate. The conjugate of this expression here is basically this. X squared plus 9, and then you have a 3 here. This term and that term are exactly the same. The only difference will be the sign. So if this was a minus, this one will be a plus. If that was a plus, this would be a minus. And then from there, we're going to do this. You're going to do the same thing at the bottom so that it's like you are remember this can cancel with that. So it's like we're multiplying with 1. We are not changing the meaning of the original equation. All right, now we can keep on going. Limit as x approaches 0. Remember now on top we have difference of two squares, right? So it means this will multiply with that, and then this one multiplies with that. Remember, for difference of two squares, we don't really care about the middle terms because they always cancel each other. So first term multiplies the first term in the second bracket. The last term in this bracket will multiply the last term there. So square root of this times square root of this, you're just going to have x squared plus 9. Here I'm using the fact that if I have square root of x times square root of x, which is the same thing under the square root, so I can have this squared, which is just x, which is that thing that was inside the square root. All right. And then it's going to be minus 9, because 3 times 3 is 9. All over x squared. And then you have this, ne? X squared plus 9 plus 3. Never ever multiply the denominator. So you have limit as x approaches 0. This 9 cancel with that. So you're going to have x squared all over x squared square root of x squared plus 9 plus 3, and then brackets here and there. You can see that this x squared will cancel with that one. So you have limit as x approaches 0 is going to be 1 over square root of x squared plus 9 plus 3. Right. And then now we can nicely substitute, because the moment you don't get 0 at the bottom when you do your substitution, that's the moment you are sorted, right? So the limit will disappear. So basically I'm having 1 over square root of 0 squared plus 9 plus 3. Take this 0, you substitute there on x. And then which becomes 1 over square root of 9 plus 3. We all know that square root of 9 is 3 plus 3, which gives us 1 over 6. And that is the answer for this limit. Right. If you haven't hit the like or the subscribe button, please do so and leave a comment, ladies and gentlemen, if you found this video helpful or if you feel like I can improve somewhere. Okay, perfect. So now let's try the second one. Here's the second one. We're going to do the second one here. So here, we're going to do one-sided limits. Ne? By one-sided limits, I mean this. So if I have a limit as x approaches a with a plus there, this means I'm moving from the right. I'm approaching it this way. Ne? And then if I have a limit, the positive means as we move from the right. Ne? From the right, from right. Sharp. And then this sometimes can be represented this way. Ne? Limit as x, then they show you this. A. They can write it like that. This means that x is going down, you see? It can only go down if you're moving from this way to that way. Sharp. Then you can write this as limit as x approaches a from the left. So sometimes this we can write it as limit as x goes up. You see? So here we're going up. So we're going to from left to right. Sharp, you must know that this and that means the exact same thing. Okay. Awesome. So now let's attempt these questions. I'm going to pick a different color. I feel like green. Okay. So let's make it green. This will be our answers. It should be easy. So here we have g of x, which is our graph, right? And then we need to know what is happening on the x value that we're interested on. It is 2, right? So I will need to know what happens here on 2 as I move from the left. As I move from the left. Okay. So I'm coming this way, basically. Right. As I'm coming this way, I'm going in this part here. You can see that the limit is approaching 3. So the first answer would be 3. Because as we reach 2 from the left, the y value that corresponds with 2 from the, as we're moving from the left, is 3. I'm sure it makes sense, ladies and gents. Now let's see what happens as we move from the right. As we move from the right, approaching the same number. So here we're moving from the right. We're approaching the same number 2. The y value that we're approaching is 1. So the y value there will be 1. All right. Awesome. And then, guys, if you check the x value that you approach as you move from the left, I mean the y value that you approach as you move from the left, and the y value that you approach as you move from the right, is not the same, but you're approaching the same number. Ne? We're approaching 2 from the left, we're approaching 2 from the right. So we're going to say the limit as we approach 2 does not exist because the left side limit is not the same as the right side limit. So here you're going to say does not exist. Your reason will be because limit as x approaches 2 from left of f of x is not equals to limit as x approaches 2 from the right of, oh, it's g of x, sorry, of g of x. That is your reason. If they say, give a reason for your answer. Okay, perfect. And then, guys, if the limits are not the same, there's a type of discontinuity that happens. We say the graph is jumping there. So here we're going to say there's a jump discontinuity. We're going to talk about discontinuity in the future, but it just came in my mind, so I'm just giving you an idea. If the limits from the left and the right are not the same, we say it is a jump discontinuity. Okay. Now let's check what happens at 5. We're interested at 5 now. Do you see? So the x value that we're going to be interested in now, it's 5. Okay. So let's see what happens on 5. What happens to the y value on 5 as we're coming from the left? Okay. As I come from the left, the y value on 5, we can all see that is corresponding to 2, right? As I'm coming this way, the y value is corresponding to 2. So here we're going to say, okay, the y value corresponds to 2. As I move from the right, the y value still corresponds to 2. So it means the limit as x approaches 5 exists, which is 2. Why? Because limit from the left as x approaches 5 is the same as limit from the right as x approaches 5. Right. But the limits existing does not necessarily mean that the function is continuous. Check there. I'm just talking about continuity and discontinuity. I mean, introducing it, but we're going to talk about it more in detail later in the sections. So now, let's check. What is g at 5? G at 5 is this point, guys. You see it? So 5 goes with 1. So g at 5 is 1. So as the limit as x approaches 5 is not the same as g at 5. The limit exists, but the point is not the same. I mean, the y value that is being approached is not the same as the y value at that point. I'm not sure if I make sense. This is what I mean, ladies and gentlemen. This is what I mean. So I'm saying here, limit as x approach 5 of g at x is not the same as g at 5. It's not the same as substituting 5 on this graph. So which means there's a discontinuity there. If this is the reason, your discontinuity, we call it removable, because we just removed the point. Removable discontinuity. So we removed this point. The point was originally here, but we removed it and put it here, you see? So we call that type of discontinuity removable. But yeah, we'll talk about that later. Okay, now let's try the last one. Ladies and gentlemen, I advise you to pause the video and attempt this question, and then continue to see how you understood the first part of this lesson. Okay, now let's answer A. On A, they say use the given graph of f to state the value of each quantity if it exists. If it does not exist, explain why. Sharp. So the first question, we're interested in 2. The second question, we're interested in 2. And the third one, we're interested in 2. You see it? So the x value equals to 2. I'm going to mark it there. Sharp. So the first one, I need to know the y value that is being approached as we move from the left, because it's negative there. So we're approaching the green dot, but from this side. So the y value that is being approached is 3. Do you see it? So the answer for the first one is 3. Now let's check B. B, what is the y value that is being approached as we're moving from the right? You can see that this point here corresponds with 1. So the answer for the second one is that. And then in overall, this limit does not exist. Why? Because the left-hand limit and the right-hand limit does not equal each other. So the limit in overall will not exist. Right, your reason is because limit as x approaches 2 from the left of f of x is not the same as the limit of f of x as x approaches 2 from the right. If they say give a reason for your answer, you give that. That is the reason why a limit does not exist. Okay. And then obviously, if the limit does not exist, you know you have a jump discontinuity. It's like there's a jump. See, there's a gap there. Okay, let's check f at 2. That is D. F at 2, we can see that is 3, guys, right? You might be tempted to say it's 1, but you can see that 1 is not shaded. So which means 1 is not included. It's just being approached. But 3 is being included. So f, when x value is 2, the y value will be that one, because it's a solid dot. So the y value will be 3. Right. Now here we're interested in 4. Because they're asking us to find the limit as x approaches 4, we are going to assume that the limit exists or does not exist. We're not sure. Let's check. So I'm going to check what happens as we approach 4. Remember, 4 is here. The x value 4 is there. I need to know what happens as I'm approaching from this side. I'm approaching the y value there, which is 4, right? Even this side, I'm approaching the same y value, right? So which means the answer for E will be 4. Right, now what is f at 4? F. Do we have f at 4? Let's see. F at 4 doesn't exist. Do you see it? Because there's nothing that is solid. There's no, here is not included because there's an open space and there's nothing here. So we're going to say f at 4 does not exist. Does not exist. Your reason is because there is no point. There is no point. And that is finito with this video, ladies and gentlemen. Thank you very much for your time. Keep on watching for more fire content. And don't forget to like, share, and hit the subscribe button. Aluta continua. Tango. Thank you very much. Thank you very much.